So this exercise is all about those angles of elevation and depression that we just learnt about in the video. We'll do example 19 together. You can find this in your textbook exercise as well, just before exercise 408. There's a couple of examples and I've just taken this one straight out of there. Okay, so the angle of elevation of a chimney is 49 degrees at a distance of 85 meters from its base. So we can draw a diagram from this information. A chimney, well, generally speaking, a chimney is just going to be represented by a vertical line, yes? Because a chimney is a tall sort of vertical tower that just goes straight up. So we can draw that chimney straight away. We can just draw that as a line. We don't have to draw the actual chimney. I mean, we can if we like. We can turn it into a chimney here, just so that we know that it's a chimney. But we're really just interested in the length of the chimney here, or the height of the chimney, should we say. So the angle of elevation of a chimney, here's our chimney. Now we've got some information about an angle of elevation. Now, because it's the angle of elevation of a chimney, that means that we're not actually standing at the chimney, okay? We're standing somewhere else. So where are we standing? It says we're standing at a distance of 85 meters from its base. So the point where the angle of elevation is drawn is actually going to be at a distance of 85 meters from the base of the chimney. So we can put that wherever we like. The base of the chimney is here. We can go 85 meters to this side. We could even go 85 meters to this side here. It doesn't matter. It just says that we're at a distance of 85 meters from the base of the chimney. So I'm going to go this way because I have more room on this side. And I know that that's a distance of 85 meters from the base of the chimney there. So I'm at this point here. Now let's read that sentence one more time. It says the angle of elevation of the chimney is 49 degrees. So the angle of elevation, we know that angles of elevation and depression always start at the horizontal. They're always measured at the horizontal. So we've got this horizontal line here. That's going to be one of our lines that form the angle, okay? And from that line, we're going to go either up or down, depending on whether or not it's an angle of elevation or an angle of depression. So in this case, it's an angle of elevation, and to elevate something is to raise it up. Depression means that it's going to be going down. So because it's an angle of elevation, we're going up from the horizontal. So make sure we're looking out on the horizontal. From there, we go up, okay, to the top of the pyramid. Because remember, it's the angle of elevation of, sorry, not pyramid, of a chimney. So we go from the horizontal and we elevate up until we get to the top of the chimney. So this line here, that's going to make up the other part of our angle. This is the line of sight from this point, 85 meters away from the base of the chimney. The angle of elevation from the horizontal is 49 degrees. So this is 49 degrees here. Sometimes the question will say the angle of elevation of the top of the chimney instead of just of a chimney, because then it's being a bit more specific. You know exactly where you're looking, where this line of sight is. So you can even imagine that there's a little person standing here, and this line of sight, that's their vision. That's their line of sight if they look straight up at the top of the chimney. Okay, so we've got a side, we've got an angle. That means we know we can probably use the trig ratios. So let's see, what's the question asking us? It's asking us to find the height of the chimney to the nearest meter. Okay, so it wants to find this height here. So let's just label that side of the triangle X, because that's what we're trying to find. And now let's just put in our trig ratios. So which one are we going to use? Well, in relation to our given angle, our angle here is 49 degrees. Which two sides do we have? You can see that, well, if this is our right angle here, That's obviously our right angle because that's the horizontal and that's the vertical chimney. So we've got our opposite side here. We're working with this side x. That's what we want to find. And we've also got our adjacent side here. This is adjacent to our angle. This is the hypotenuse up here. We're not really interested in that and we don't have any information about it. So we've got opposite and adjacent. So which ratio are we going to use? We're going to use TOLA, which stands for tan. It's the tangent ratio. So if we write that out properly, TOLA actually stands for tan of an angle is equal to opposite over adjacent. And now we can plug in our values. So our angle is actually 49 degrees. So we can put 49 degrees in there. And our opposite side is x. And our adjacent side was 85. So now we've got an equation. We've only got one unknown over here, x. So we need to solve for x. The way we do that is we want to isolate x and get x by itself. So we need to get rid of this division by 85. We can use inverse operations to get rid of it. So we just multiply both sides by 85. And then we're left with 85 times tan 49 on the left-hand side. And this is just an expression that we can do on our calculator. So 85 times tan 49. That gives us a value of 97.78, full stop there, equals, on the right hand side we've got x. So we've found x here. And the question asks to find the height of the chimney to the nearest meter, okay? So at the moment we've got x equals 97.78 meters because this was measured in meters, so this is meters too. And we just need to round off to the nearest meter. So that means that x is going to be 98 meters.